We'll start in 1 minute. Today we'll cover section 9.5 on solving trigonometric equations. So a number of things that we use in regular algebra will also be used when solving trigonometric equations. Hey, we'll start with this equation. We want to find exact solutions on the interval from 0 to 2 pi, but excluding 2 pi. So 2 times sine of theta equals negative square root of 2. First, divide both sides by 2, and we get sine of theta equals negative square root of 2 over 2. And we know two numbers between 0 and 2 pi where sine of theta is equal to negative square root of 2 over 2. One is theta equals 5 pi over 4, and the other one, theta equals 7 pi over 4. 5 pi over 4 is in the third quadrant, and 7 pi over 4 is in the fourth quadrant, and sine is negative in those two quadrants. Okay, the next equation, 2 times sine of 2 theta equals the square root of 3. So first, divide both sides by 2, so we get sine of 2 theta equals the square root of 3 over 2. So we have to find all values of theta such that sine of 2 theta equals the square root of 3 over 2. Well, we know 2 theta can be pi over 3, because sine of pi over 3 is the square root of 3 over 2. And we also know that 2 theta is equal to 2 pi over 3 in the second quadrant. Okay, but we're solving for theta. So if we divide both sides by 2, one solution is theta equals pi over 6. And another theta value is theta equals pi over 3. Okay, but there are more values between 0 and 2 pi besides pi over 6 and pi over 3. Let's consider the function y equals sine of 2 theta. The period of this function is 2 pi divided by 2, or pi. So if we were to sketch a graph of y equals sine of 2 theta in the theta y plane, we're not using x, we're just using theta for the domain variable. That's okay. And so we get 1 period of pi between 0 and pi. So between 0 and pi, if we subdivide these to pi over 4, pi over 2, 3 pi over 4, and we'll sketch 1 period something like that. Okay, so the two values of theta that we found are pi over 6. Pi over 6 is to the left of pi over 4. And pi over 3 is to the right of pi over 4. And so we found two solutions. But we want to find all solutions between 0 and 2 pi. So if we sketch another period of the same function and go all the way to 2 pi, let's see, this will be 5 pi over 4, then 3 pi over 2, 7 pi over 4. And we get one more period of this function. And we can see that if we draw a horizontal line, this will intersect the curve in two more places, where the height of that is the square root of 3 over 2. So between 0 and 2 pi, there are two more solutions for theta. Okay, we'll notice that this point right here is 1 period of this function away from pi over 6. And the other one, this other point, compared to this one, this point is 1 period away from that one. So how do we find the other two solutions? Well, we can just add pi to each of those two. And pi over 6 plus pi is 7 pi over 6. So that's this one. And the fourth solution is pi over 3 plus pi, which is 4 pi over 3. Okay, so the thing to remember, if you have sine of 2 theta equals a positive number, there's going to be 4 solutions between 0 and 2 pi. Okay, the next example. So we're just going to encounter a number of equations, trigonometric equations, that we're going to attempt to solve for x, or whatever the domain variable is. And we can also use some identities whenever they're useful. So on this one, solve this equation: 2 times sine of x times cosine of x minus sine of x plus 2 times cosine of x minus 1 equals 0. Well, there might be a number of different things that you think that you could try. Sometimes things that you try don't work out too well. But I think what I'm going to do is I'm going to factor sine of x out of the first two terms, factor out sine of x, and then we're left with 2 times cosine of x minus 1, and then plus, and I notice I have a 2 times cosine of x minus 1 here. So I'm going to write it as 1 times the quantity, 2 times cosine of x minus 1. It's not required, but if I write it this way, it might help to see that we're going to factor 2 times cosine of x minus 1 out of those terms. So we factor 2 times cosine of x minus 1. The other factor is sine of x plus 1. And now we use a familiar property from arithmetic and algebra, the zero product property. If the product of 2 factors is 0, to find the solutions, set each factor equal to 0 and solve for the variable. So one of the factors is 2 times cosine x minus 1, so we set that equal to 0. The other factor is sine of x plus 1, so we set that equal to 0. And then if we add 1 and then divide by 2, we get cosine of x is equal to 1/2. And here we just subtract 1 from both sides. Sine of x equals -1. Okay, so it looks like for this equation, we're going to have 3 solutions. There are 2 values of x between 0 and 2 pi, for which cosine of x is 1/2. One of those is pi over 3. And then also in the fourth quadrant, if x is 5 pi over 3, then cosine of 5 pi over 3 is equal to 1/2. Sine of x equals -1. There's only one number between 0 and 2 pi where sine of x is equal to -1, and that's x equals 3 pi over 2. Okay, in the next example, cosine of 2x equals sine of x. Well, here we can use a double angle formula for cosine of 2x. So cosine of 2x, the most basic of the double angle formulas for cosine of 2x, is cosine of x squared minus sine of x squared. So it might be worthwhile reviewing, since you'll be tested over this double angle formulas on next Monday. Cosine of 2x is cosine of x plus x, and then apply the sum formula for cosine. Cosine of x plus x is cosine of x times cosine of x minus sine of x times sine of x, which is cosine squared x minus sine of x squared. So that's where that came from. 2 of my terms involve sine of x. The other one is cosine of x. So I'm going to replace cosine of x with 1 minus sine of x squared. Did I say that right? I'm going to replace cosine of x squared with 1 minus sine of x squared using one of the Pythagorean identities. And now I get an equation that's in terms of sine and a constant. So if we combine like terms, we get 1 minus 2 times sine of x squared equals sine of x. Okay, so what I'm going to do is I'm going to add 2 times sine of x squared to both sides and subtract 1 from both sides. So if I do that, I get 0 equals 2 2 times sine of x squared plus sine of x minus 1. So this equation is quadratic in form. So we can factor it. Well, we can factor this one. So I'll just do it by trial and error. One of the factors will have 2 times sine of x. The other one will have sine of x. So since I have a plus sine of x, I need this to be plus 1 and this to be minus 1. And then you can verify just by looking that these are the correct factors. And since the product of those two factors is 0, we set each factor equal to 0 again. So 2 times sine of x minus 1 is 0. The other factor, sine of x plus 1, set that equal to 0. So here add 1 and divide both sides by 2. We get sine of x equals 1/2. And then over here subtract 1, sine of x equals -1. And for x values between 0 and 2 pi, sine of x has two solutions when sine of x equals 1/2. One is x equals pi over 6, and the other one is x equals 5 pi over 6. 5 pi over 6. And then sine of x equals -1 when x is 3 pi over 2. Okay, the next equation tangent of x squared minus the square root of 3 times tangent of x equals 0. This is also quadratic in form. Here we can factor tangent of x out, and the other factor is tangent of x minus the square root of 3, and the product is 0. So we set tangent of x equal to 0. And when we set tangent of x minus the square root of 3 equal to 0, we can just add the square root of 3 to both sides, so we get the tangent of x equals the square root of 3. Okay, between 0 and 2 pi, tangent of x equals the square root of 3 has two solutions. One is in the first quadrant, and the other one is in the third quadrant. Those are the only quadrants where tangent of x is equal to a positive number. And tangent of x equals 0. Well, tangent of x equals 0 when x is 0. And then it's also, tangent of x is also equal to 0 when x equals pi. Tangent of x is equal to 0 when x equals 2 pi. But here we're assuming that the solutions are on the interval from 0 to 2 pi, but excluding 2 pi. So we don't include 2 pi as a solution in this case. Okay, so tangent of x equals the square root of 3 in the first quadrant when x equals pi over 6, because that's, whoops, I'm sorry, I made a mistake, pi over 3. So let's write down the other solution, x equals 4 pi over 3 in the third quadrant. So I need a tutorial on tangent of x. So tangent of pi over 3, I'm just going to verify that tangent of pi over 3 is equal to the square root of 3. So tangent of pi over 3 is the sine of pi over 3 divided by cosine of pi over 3. Sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 3 is 1/2. And sure enough, that simplifies to the square root of 3. Okay. Okay, so that equation has 4 solutions. Okay, the next equation, cosine of 2x minus cosine of x equals 0. So let's start with the double angle formula for cosine of 2x. Let's write it as cosine of x squared minus sine of x squared, and then minus cosine of x equals 0. So this time I'm going to replace sine of x squared with 1 minus cosine of x squared. So we get cosine of x squared and then minus, I'm going to put the quantity in brackets. So we're going to subtract the quantity 1 minus cosine of x squared, and then minus cosine of x equals 0. Then we'll distribute subtraction. Cosine of x squared minus 1 minus cosine of x squared is plus cosine of x squared minus cosine of x equals 0. So we have another equation that's quadratic in form. So we'll put it in its standard form. 2 times cosine of x squared minus cosine of x minus 1 equals 0. So we can factor this again. The factoring is pretty nice. 2 times cosine of x in one factor and cosine of x in the other. And this time I need a minus 1 over here and a plus 1 over here because the middle term is minus cosine of x. Okay, so set each factor equal to 0. 2 times cosine of x plus 1, set that equal to 0. Then subtract 1 and divide both sides by 2. We get cosine of x equals negative 1/2. And then cosine of x minus 1 equals 0 means cosine of x equals 1. For x values between 0 and 2 pi, excluding 2 pi, cosine of x equals negative 1/2 has 2 solutions. So one of those is in the second quadrant when x is 2 pi over 3. Cosine of 2 pi over 3 is equal to negative 1/2. And then also in the third quadrant, x equals 4 pi over 3. And cosine of x equals 1 when x is 0. It also equals 1 when x is 2 pi, but we're excluding 2 pi. Okay, the next one, this term should be minus 5 times sine of x. So we have a mistake. So solve this equation instead. 6 times sine of x squared minus 5 times sine of x plus 1 equals 0. Well, this factors pretty nicely. So I'll put 3 sine of x in one set of parentheses and 2 sine of x in the other. And it looks like I need a minus 1 in both factors. So that's easy to verify that those are the two factors. So set this factor equal to 0, and then add 1 and divide by 3, we get sine of x equals 1/3. And this one, add 1 and divide by 2, we get sine of x equals 1/2. Okay, sine of x equals 1/2. That's pretty easy. Between 0 and 2 pi, x is pi over 6 and 5 pi over 6 in the first and second quadrants. And sine of x equals 1/3 also has two solutions. It doesn't involve a special angle. But let's draw a picture and see what we have to do. So one of the solutions is x equals the inverse sine of 1/3. So this is in the first quadrant. So the first quadrant, if we have this angle, which is the inverse sine of 1/3, how do we find the other solution? The other solution is in the second quadrant. Well, if we draw the reference angle over here, the size of this reference angle is the inverse sine of 1/3, if you can read that. And we want to know what this angle is. So this angle is just pi minus the reference angle. So in other words, the other solution is x equals pi minus the inverse sine of 1/3. The same logic applies if we focused on the solution x equals pi over 6. So let's just draw that x equals pi over 6. And then over in the second quadrant, we have a reference angle of the same size, pi over 6. And so this angle is pi minus the reference angle, pi over 6, which we already know is 5 pi over 6. So in a case like this, where where a special angle is not involved, you can use more elementary things that you know about to help you determine how to write the other solution. Okay, the next example, sine of x squared times 1 minus sine of x squared plus cosine of x squared times the quantity 1 minus sine of x squared equals 0. So notice we have a 1 minus sine of x squared in both places. So if we factor that out of those terms, we get 1 minus sine of x squared times sine of x squared plus cosine of x squared. But sine of x squared plus cosine of x squared is 1. It's equal to 1. And so we're just left with 1 minus sine of x squared equals 0. 1 minus sine of x squared is a difference of squares. You've seen this factored a few times already this semester. So if we factor that, we get 1 minus sine of x times 1 plus sine of x equals 0. Set each factor equal to 0, we get sine of x equals 1 and sine of x equals negative 1. Between 0 and 2 pi, sine of x equals 1 only has one solution. It's x equals pi over 2. And also between 0 and 2 pi, sine of x equals negative 1 only has one solution. It's x equals 3 pi over 2. We'll throw in some word problems. This one says an airplane will fly 200 miles to a location in a northeasterly direction. If the latitudes of the start and end points differ by 25 miles, find the number of degrees north of east the airplane will fly. Okay, if you look at a map, horizontal to the right is the direction east, and vertically up is the direction north. So we'll put this point right here as the start point, the place where the airplane took off. And it's headed in a northeasterly direction. It says the latitudes of the start and end point differ by 25 miles. So on a map, and also on a globe of the Earth, the horizontal lines are the latitudes. So there's one latitude, and here's another latitude. The latitudes are parallel. So let's just say that this point right here is the end point. And the airplane flew from here to there. And that distance is 200 miles. But the latitudes differ by 25 miles. So the distance from the latitude above and the latitude below is 25 miles. Okay, the angle north of east is this angle. Let's call it theta. So that's east, that's north. So theta degrees north of east is what you get when you move counterclockwise theta degrees. Well, this is pretty easy to figure out. The sine of theta is 25 over 200, or 1/8. And so theta is the inverse sine of 1/8. And they want it measured in degrees. Okay, so that's all there is to that one. The next problem, at the instant that a building 90 feet tall casts a shadow that is 2 feet long, find the angle of depression from the top of the building to the edge of the shadow. Okay, so if we have a building and the sun casts a shadow, okay, so the shadow is 2 feet. The height of the building is 90 feet. And it says find the angle of depression. So from the top of the building, from this point, remember, look horizontally. The angle of depression is the angle formed by the horizontal and the ray of the sun there. So this is the angle of depression. You can see that that's different than this angle right here. In general, it will be different. The only time they would be equal is if the shadow is the same length as the height of the building. Okay, well, we can use algebra to help us, or sorry, not algebra, geometry to help us. Remember from geometry, if two lines are parallel and both are intersected by a transversal, then alternate interior angles are congruent. So this angle right here, the measure of this angle is the same as the angle of depression. So I might as well write it. This has the same measure as the angle of depression. Okay, so no doubt you've already finished this problem. We can find this angle by using tangent. The tangent of that angle is 90 over 2. So we might as well call it theta. The tangent of theta is 90 over 2, or 45. So the angle of depression, theta, is the inverse tangent of the number 45. Okay, next problem. A ladder 23 feet long is leaning against the wall of a building. For safety reasons, the base of the ladder is just 7 feet from the building's base. So find the angle of elevation from the base of the ladder to the top of the ladder. Okay, so we have a building and a ladder that's 23 feet. And the base of the ladder is 7 feet from the base of the building. Find the angle of elevation from the base of the ladder to the top of the ladder. Okay, so from the base to the top, the angle of elevation is this angle, theta. Okay, so what do we do this time? So we have options, but it looks like the most straightforward thing to do is to use the cosine function. Cosine of theta is equal to the length of the adjacent side divided by the hypotenuse. So cosine of theta is 7/23, and theta is the inverse cosine of 7/23. Okay, we'll move on to the next page. Find exact solutions on the interval from 0 to 2 pi. Sine of x plus 1 equals cosine of x. Well, if you think about that equation, you can eventually find a solution just by thinking of a particular special angle. But otherwise, it sort of seems a little confusing. So one technique is to square both sides. So if we square both sides, sine of x plus 1 squared equals cosine of x squared. When we square sine of x plus 1, we get sine of x squared plus 2 times sine of x plus 1 equals cosine of x squared. But since the terms on the left-hand side involve sine, I'm going to replace cosine of x squared with 1 minus sine of x squared. And then we'll focus on solving an equation that's quadratic in form. So we'll add sine of x squared to both sides, and then subtract 1 from both sides. And I get 2 times sine of x squared plus 2 times sine of x. And when I subtract 1 from both sides, the 1's are eliminated, so I get 2 times sine of x squared plus 2 times sine of x equals 0. So we can factor 2 times sine of x out. And then we're left with sine of x plus 1. Okay, then set the factors equal to 0. If 2 times sine of x is 0 and then divide both sides by 2, I get sine of x equals 0. And set the other factor equal to 0. Sine of x plus 1 equals 0. Sine of x equals negative 1. Okay, sine of x equals 0 for values of x between 0 and 2 pi. Excluding 2 pi, we get x equals 0 and x equals pi. And sine of x equals negative 1 when x is 3 pi over 2. Okay, we started out by squaring both sides of the equation. So we have to be aware that we might have introduced extraneous solutions. So this is something that you no doubt saw in a lower division algebra class. Look for extraneous solutions. So we'll just visually check to see if these work or not. If x is 0, sine of 0 is 0, cosine of 0 is 1, and 1 equals 1 is true. So x equals 0 works. What about x equals pi? Well, sine of pi is 0. Cosine of pi is -1, and 1 equals -1 is false. So x equals pi is not a solution. And then our other solution, if x is 3 pi over 2, sine of 3 pi over 2 is -1. -1 plus 1 is 0. And cosine of 3 pi over 2 is 0. Okay, so the equation has just two solutions. We would say that x equals pi is extraneous. Okay, the next equation, cosine of 3x plus cosine of x. So what are we going to do this time? So think of cosine of 3x as cosine of 2x plus x, and then plus cosine of x. And then use the sum formula for cosine. Cosine of 2x plus x is cosine of 2x times cosine of x minus sine of 2x times sine of x, and then plus cosine of x equals 0. So this looks like it's going to get worse before it gets better. Cosine of 2x, I'm going to use the double angle formula, the more familiar one, and write this as cosine of x squared minus sine of x squared times cosine of x. And then the double angle formula for sine of 2x is 2 sine of x cosine of x, but we're multiplying that by sine of x, and then plus cosine of x equals 0. Okay, now what? Well, I think what I want to do is replace this sine of x squared with 1 minus cosine of x squared. And I have another sine squared over here when I multiply those. So I'm going to replace this sine of x squared by 1 minus cosine of x squared also. So I'll get cosine of x squared and then minus 1 minus sine of cosine of x squared. I'm going to get another plus cosine of x squared and then minus 1. This is all multiplied by cosine of x. And then I'm going to replace the sine of x times sine of x with 1 minus cosine of x squared and multiply that by cosine of x. So now at least everything is written in terms of cosine. So in this set of parentheses, we have 2 cosine of x squared minus 1. So when we multiply each of those by cosine of x, we'll get 2 cosine of x to the third minus cosine of x. And over here, I'm going to get a minus 2 times cosine of x and plus 2 cosine of x to the third. And then plus cosine of x equals 0. Okay, so we do get a cancellation, the minus cosine of x and the plus cosine of x. And when we combine like terms, we have a total of 4 cosine of x to the third minus 2 times cosine of x equals 0. So now let's factor 2 times cosine of x out of each of those terms. So we get 2 times cosine of x. And then we're left with 2 cosine of x squared minus 1 equals 0. So now we're getting somewhere. One of the factors is just 2 times cosine of x, or cosine of x equals 0. So the two solutions we get for this between 0 and 2 pi are pi over 2 and 3 pi over 2. And then the other factor, I'll go ahead and write it, 2 times cosine of x squared minus 1 equals 0. So if we add 1 to both sides and divide both sides by 2, and then take the square root, we get cosine of x equals positive and negative 1 over the square root of 2. Okay, so this equation, cosine of x equals 0, that gives us 2 solutions, as we already mentioned. So I'll write those up here, x equals pi over 2, and x equals 3 pi over 2. And look what we have here. Cosine of x equals positive and negative 1 over the square root of 2. Well, this is equivalent to the square root of 2 over 2. So we recognize that as involving special angles. So between 0 and 2 pi, this equation has 4 solutions because we have both positive square root of 2 over 2 and negative square root of 2 over 2. So one solution is pi over 4. Another one is 3 pi over 4. Third one is 5 pi over 4. And finally, 7 pi over 4. Well, the next one will seem easy by comparison. We just have a trigonometric equation that is quadratic in form. So we can factor this one. So let's see. If we make this a minus 3 and a plus 1, I think that does it. Yeah. Okay, so set each factor equal to 0. If 2 times cosine of x minus 3 is 0, we add 3 and divide by 2. We get cosine of x equals 3/2. And the other one, cosine of x equals -1. Well, cosine of x equals 3/2 can never happen. This has no solution. And the reason is the range of cosine of x is from -1 to 1. So -1 is less than or equal to cosine of x, which is less than or equal to 1. It's a small but very important detail to remember. And then cosine of x equals -1. Well, there's just one number between 0 and 2 pi, where cosine of x is equal to -1. That's 3 pi over 2. Okay, we keep going. Tangent of x plus 1 equals secant of x. Well, let's try squaring both sides again. So tangent of x plus 1 quantity squared equals secant of x squared. Okay, so when we square tangent of x plus 1, we get tangent of x squared plus 2 times tangent of x plus 1 equals, well, I think I want to replace secant of x squared using one of the Pythagorean identities. I replace that with something in terms of tangent of x squared. So if you don't remember it directly, hopefully you'll at least remember sine of x squared plus cosine of x squared equals 1. And let's see, what do we do to get the tangent of x squared and the secant of x squared? Well, we divide every term by cosine of x squared. So divide by cosine of x squared every term. And so we get tangent of x squared plus 1 equals secant of x squared. So we'll just replace, on the right-hand side, we'll just replace that with tangent of x squared plus 1. And then, if we subtract tangent of x squared from both sides and subtract 1 from both sides, we're left with 2 times tangent of x equals 0. Divide both sides by 2, tangent of x equals 0. Okay, well, between 0 and 2 pi, tangent of x equals 0 when x is 0 and when x is pi. Okay, but we should check. We started out by squaring both sides, so we might have we might have an extraneous solution. So if we check x equals 0, well, this one works out. Tangent of 0 plus 1 equals secant of 0. This is 1 over cosine of 0. But cosine of 0 is 1, so x equals 0 works. What happens when we test x equals pi? Well, we do know that tangent of pi is 0. And secant of pi equals 1 over cosine of pi. Cosine of pi is -1. So x equals pi is not a solution. Turns out that x equals 0 is the only solution. Okay, the next one, secant of x squared minus tangent of x equals 1. Well, a couple of minutes ago, we used the fact that secant of x squared equals tangent of x squared plus 1. So let's use that here. Replace secant of x squared with tangent of x squared plus 1. And if we subtract 1 from both sides, we get tangent of x squared minus tangent of x equals 0. Factor out tangent of x. So we get tangent of x times the quantity tangent of x minus 1 equals 0. So tangent of x equals 0. And then when we set tangent of x minus 1 equals 0, add 1 to both sides, we get tangent of x equals 1. Okay, between 0 and 2 pi, excluding 2 pi, x equals 0 and x equals pi are solutions. And then tangent of x equals 1 twice for x values between 0 and 2 pi. So 1 is in the first quadrant, x equals pi over 4. And then in the third quadrant, x equals 5 pi over 4. Okay, this one, let's set one side equal to 0. You might be tempted to divide both sides by tangent of x, but you don't ever want to do that because you'll most likely annihilate one of the solutions by doing so. So in particular, it's almost like trying to divide by 0. So the best thing to do is set one side equal to 0 and then factor the other side. So first we'll subtract tangent of x from both sides. And then we'll factor tangent of x out. So we get tangent of x times sine of x squared minus 1. We have a difference of squares, so this can be factored. So let's go ahead and write the factors out. One is sine of x minus 1, and the other one is sine of x plus 1. And then we set each of those equal to 0. Tangent of x is 0. Sine of x minus 1 is 0. And sine of x plus 1 is 0. Okay, between 0 and 2 pi, tangent of x is equal to 0 when x is 0 and x equals pi. Okay, so these would be the two solutions that would have been annihilated if you divided both sides by tangent of x. So watch out for that. Okay, sine of x minus 1 equals 0, so sine of x equals 1. Between 0 and 2 pi, this occurs only once when x is pi over 2. And then sine of x equals negative 1 when x is 3 pi over 2. Okay, the next one. This one might be tricky, might seem tricky. So we want to find all values of x between 0 and 2 pi such that cotangent of x minus pi over 4 equals negative 1. Well, we know that cotangent is equal to negative 1 for two values between 0 and 2 pi, just by itself. Let's see. Cotangent of 3 pi over 4 is negative 1. This is in the second quadrant. Cotangent is positive in the third quadrant, but in the fourth quadrant, cotangent of 7 pi over 4 is negative 1. So let's see what happens when we just write x minus pi over 4 equals 3 pi over 4. And then x minus pi over 4 equals 7 pi over 4. Remember, the goal is to solve for x. So if we add pi over 4 to 3 pi over 4, we get x equals pi. And then when we add 7 pi over 4 to pi over 4, we get x equals 8 pi over 4, but that's 2 pi. But if we're only admitting x values that are between 0 and 2 pi and excluding 2 pi, then this is not a valid solution. So only solutions from the interval from 0 to 2 pi are accepted for whatever reason. But Okay, but there is another solution. So what is it? So x equals pi is a solution. So this might seem tricky. X equals 0 is a solution. 0 is in the interval from 0 to 2 pi, including 0. X equals 0 is a solution. So why is that? Well, if you replace x with 0, the cotangent of 0 minus pi over 4 is equal to the cotangent of negative pi over 4, which is equal to negative 1. So x equals 0 and x equals pi are the two solutions. Okay, the next one on this page, 1 plus 2 times cosine of x over 2 equals 0. Okay, so let's subtract 1 from both sides and then divide both sides by 2. We get cosine of x over 2 equals negative 1/2. Well, we know what values at which cosine is negative 1/2. So if, let's see, we know, what do we know? We know that cosine of 2 pi over 3 is equal to negative 1/2. That's in the second quadrant. And we also know in the third quadrant, cosine of 4 pi over 3 is equal to negative 1/2. Okay, so if we set x over 2 equal to those, x over 2 equals 2 pi over 3, and x over 2 equals 4 pi over 3, and then solve for x. That's the goal, solve for x. So multiply both sides by 2, we get x equals 4 pi over 3. Multiply both sides of this by 2, we get x equals 8 pi over 3. But notice that 8 pi over 3 is 2 pi plus 2 pi over 3. This is greater than 2 pi. So if our solutions are only from 0 to 2 pi, excluding 2 pi, then x equals 8 pi over 3 is not listed as a solution because it's greater than 2 pi. Okay, so let's discuss this just briefly. Consider the function y equals 2 times cosine of x over 2. So what's the period of this function? The period is 2 pi divided by 2, or 4 pi. So I'll draw one period of that. Between 0 and 4 pi is one period of this one. So the amplitude is 2. So when we graph this period of length 4 pi, we get this. So remember the equation that we were solving? Cosine of x over 2 equals negative 1/2. So negative 1/2 is about right here. But between 0 and 2 pi, there's only one solution. The other solution is between 2 pi and 3 pi. Okay, next page. Find the exact solutions on the interval from 0 to 2 pi, excluding 2 pi. So we can add 2x to both sides. So we get 2 times sine of x equals the square root of 2. And then divide both sides by 2. Sine of x equals the square root of 2 over 2. So the solutions involve special angles. Sine of x equals the square root of 2 over 2 when x equals pi over 4 in the first quadrant and 3 pi over 4 in the second. So that seems pretty easy. The next one, negative 1 plus sine of x over 2 equals 0. So add 1 to both sides. Sine of x over 2 equals 1. And we know that sine of x over 2 equals 1 when x over 2 equals pi over 2. So we solve for x. X equals pi. Well, pi is between 0 and 2 pi, so that's the only solution. Okay, then the next one, sine of x minus pi over 3 equals negative square root of 2 over 2. Well, let's see what happens if we just go straight forward. We know that sine of 5 pi over 4 is negative square root of 2 over 2, and sine of 7 pi over 4 equals negative square root of 2 over 2. So let's just write those down to start with. X minus pi over 3 equals 5 pi over 4. And x minus pi over 3 equals 7 pi over 4. From the third and fourth quadrants where sine is negative. So if we add pi over 3, x equals 5 pi over 4 plus pi over 3. So the common denominator is 12. I have to multiply 5 pi times 3, which is 15 pi, and add 4 pi to it, so I get 19 pi. So 19 pi over 12, that's less than 2 pi, so that's a valid solution. for x. Then the next one we add seven pi over 4 to pi over 3. Common denominator is 12 again. So in the numerator, 3 times 7 pi is 21 pi, plus 4 pi is 25 pi. But 25 pi over 12 is greater than 2 pi. So we cannot list that as a solution. Well, we'll do, there is another solution. We'll do what we did the last time. Remember, it's x that has to be between 0 and 2 pi. And we know that sine of negative pi over 4, so I'll write that. We know sine of negative pi over 4 is negative square root of 2 over 2. So we set x minus pi over 3 equal to negative pi over 4. And if upon solving for x, we get an x value that's between 0 and 2 pi, then we know that we have our other solution. Okay, so add pi over 3 to both sides. So x equals pi over 3 minus pi over 4. The common denominator is 12. So 4 times pi, and then minus 3 times pi. So we get positive pi over 12, which is in the appropriate interval between 0 and 2 pi. So that is our second solution. Okay, the next problem, next equation, 4 times cosine of x squared minus 3 equals 0. So what we can do, we can add 3 and divide both sides by 4, and then apply the square root property. So we get cosine of x squared equals 3/4. And so cosine of x equals positive and negative square root of 3/4, or positive and negative square root of 3 over 2. Between 0 and 2 pi, we know there are going to be 4 solutions. So we know that cosine of pi over 6 is the square root of 3 over 2. And we know that cosine of 5 pi over 6 is negative square root of 3 over 2. So pi over 6 is from the first quadrant, 5 pi over 6 from the second. From the third quadrant, cosine of 7 pi over 6 is equal to negative square root of 3 over 2. And then finally, from the fourth quadrant, cosine of 11 pi over 6 is equal to positive square root of 3 over 2. So 4 solutions. Okay, so 2 times tangent of x equals the square root of 3 minus the tangent of x. So if we add tangent of x to both sides, we'll get 3 times tangent of x equals the square root of 3. And then divide both sides by 3, we get tangent of x equals the square root of 3 over 3. It might help to think of that as 1 over the square root of 3. So this reminds me that what angle is involved if I think of it as tangent of x over equals 1 over the square root of 3. Well, we know that x is equal to pi over 6. That's one of the solutions in the first quadrant. And then in the third quadrant, 7 pi over 6. So those are the only 2 solutions. Okay, in the next example, next equation, sine of 3x plus sine of x equals 0. So that looks familiar. Did we solve that one already? Well, it doesn't hurt to practice. Think of sine of 3x as sine of 2x plus x, and then plus sine of x equals 0. Then use the sum formula for sine. So sine of 2x plus x is sine of 2x times cosine of x plus cosine of 2x times sine of x plus sine of x equals 0. Okay, then sine of 2x, use the double angle formula. Sine of 2x is 2 times sine of x times cosine of x. And then we're multiplying that by cosine of x. And then replace cosine of 2x. So I'll just use the standard cosine of x squared minus sine of x squared times sine of x. Well, this is similar to one we did, but a little bit different. So in this one, since I have a cosine of x squared, I'm going to replace this with 1 minus sine of x squared. So we get 2 times sine of x times 1 minus sine of x squared. And then here, I'm going to replace cosine of x squared with 1 minus sine of x squared. So altogether inside that set of parentheses, we'll have 1 minus 2 times sine of x squared times sine of x plus sine of x equals 0. So I suppose when we multiply these out, I guess it'd be better just to multiply them out and then combine like terms. So 2 times sine of x minus 2 times sine of x cubed plus sine of x minus 2 times sine of x cubed plus sine of x equals 0. And now we can combine like terms. So we're going to get negative 4 times sine of x cubed, and then plus 4 times sine of x equals 0. Yeah, that looks right. And then I'm going to factor out negative 4 sine of x. Negative 4 sine of x. So we'll be left with sine of x squared minus 1 equals 0. So this isn't going to turn out to be too bad. One of the factors, negative 4 times sine of x equals 0. So that amounts to sine of x equals 0. So between 0 and 2 pi, that has two solutions. And then the other, we have a binomial factor. Sine of x squared minus 1 is a difference of squares. So sine of x minus 1 times sine of x plus 1 equals 0. Okay, so we know what all the solutions are. Sine of x equals 0 when x is 0 and x equals pi. Sine of x minus 1 is 0 when x equals pi over 2. And sine of x plus 1 is equal to 0 when x equals 3 pi over 2. Okay, more of the same. The next one is a trigonometric equation that's quadratic in form. So we can factor this one. So in one factor, I'll write 2 times sine of x, and the other one, I'll write sine of x. And let's see if this is plus 4 and minus 1, that'll get it for us. Plus 4 and minus 1. So you can verify that if it works or not. Yeah, that works. So one of the factors, 2 times sine of x minus 1, when we set this equal to 0, we add 1 to both sides and then divide both sides by 2. We get sine of x equals 1/2. Set the other factor equal to 0. Sine of x plus 4 equals 0. So sine of x equals negative 4. So this one has no solution because the range of sine of x is between negative 1 and positive 1. And then sine of x equals 1/2 has two solutions between 0 and 2 pi. One is x equals pi over 6, and the other one is 5 pi over 6. Okay, the next problem, next equation to solve. Cosecant of x squared minus 1 equals cotangent of x. So we can use a Pythagorean identity to help. So I never remember. So I'm going to write down the original. Sine of x squared plus cosine of x squared equals 1. So let's see. If I divide everything by sine of x squared, I'll get the one that I'm after. Sine of x squared so I get 1 plus cotangent of x squared equals cosecant of x squared. So I'm going to replace cosecant of x squared with 1 plus cotangent of x squared. So I get 1 plus cotangent of x squared minus 1 equals cotangent of x, or cotangent of x squared equals cotangent of x. So if you are tempted to divide both sides by cotangent of x, well, that will lead to an annihilation of a solution. So instead of doing that, set one side equal to 0. So we'll subtract cotangent of x from both sides, and then factor out cotangent of x. And then cotangent of x, set that equal to 0. Set the other factor equal to 0. Cotangent of x minus 1 equals 0, and then add 1 to both sides. You get cotangent of x equals 1. Okay, so between 0 and 2 pi, cotangent of x is equal to 0 when x is pi over 2 and 3 pi over 2. And cotangent of x is equal to 1 in the first quadrant when x equals pi over 4, and also in the third quadrant when x is 5 pi over 4. Well, I ran out of problems to do. Well, I can make up something for 2 or 3 minutes. So how would you go about simplifying something like sine of, say, 75 degrees times cosine of 15 degrees? It would help if you could see it, I guess. Sine of 75 degrees times cosine of 15 degrees. So this is a product. If you can think of the product to sum formula, then we could use that to simplify, or we could try to evaluate sine of 75 degrees times cosine of 15 degrees. Yeah, well, what if you just can't think of it? Well, remember the identities that we used to derive the product to sum formulas. So if you have a sine of an angle multiplied by cosine of another angle, perhaps it involves sine of, say, alpha plus beta. So this is sine of alpha times cosine of beta. plus cosine of alpha times sine of beta. And then the other one, sine of alpha minus beta. This is sine of alpha times cosine of beta minus cosine of alpha times sine of beta. If you add those, then we're going to get 2 sine of alpha cosine of beta. So we get sine of alpha plus beta plus sine of alpha minus beta, and 2 times sine of alpha times cosine of beta. And then divide both sides by 2, we get sine of alpha times cosine of beta equals 1/2 times sine of alpha plus beta plus sine of alpha minus beta. So we can use this to evaluate that. We can write 1/2 times sine of 75 plus 15, or 90, and then plus sine of 75 minus 15, or 60, which we know how to evaluate because those are special angles. Okay, so we're over time. That'll be all for today. We'll continue on in Chapter 10 starting tomorrow.